Hey everybody, this is Mr. Bullock here, and this lesson is for our SAT class, Systems of Equations. So these are the types of questions you'll see. Well, we'll first review how to solve systems of equations, you guys, and then we'll do a couple of application problems, things that you might see like on the SAT. All right, so there's a few good ways to solve systems. The most two common are the substitution method and the elimination method. So here's a substitution one. So solve this system using substitution. So 2x here, 5y here. Here's a 1x. Let's solve for this 1x, and we'll go minus 3y minus 3y. And then we'll go ahead and substitute this into this x right here, okay? And so there it is right there, and then we'll distribute that 2 through and then combine like terms, and we get y equals 11. And we got to write it as an ordered pair, so we got to get x over here, so we'll plug in 11 right there. So 3 minus looks like 33 is going to get us negative 30. So write it as an ordered pair, x, y, so negative 30 comma 11. Okay, here's another one. Solve this one using the elimination method. Okay, now notice they're not written right underneath each other right here. This one is not underneath here like it is in your textbook. And this is how it's going to be on the SAT if they ask you to do something like this. It'll be written like this. And you just got to look at the coefficients. Okay, a 3x and a 6x, a 7y and an 8y. It's easiest to get both the x's to be 6, and I like to do make them opposite signs of each other. So I'm going to make I'm going to make change this first one, multiply this by negative 2, and that's going to get us a negative 6x. But this times negative 2, this times negative 2. So that's what this says right here. So 3x times negative 2 is negative 6x, negative 7y. Watch out, there's a negative right there. A negative times a negative is going to get us this positive 14y. And then negative 2 times 10. Okay, now let's just slide this guy right down below that, and we'll go ahead and solve. And we get y equals negative 2 there. So here's because 14y minus 8y is 6y, and then negative 20 plus 8 is negative 12, so divide by 6. And then don't forget you got to find out x, so plug it back into either equation. I chose to plug y equals negative 2 right here. Okay, so again, a negative times a negative is a positive 14, so we subtract 14 from both sides, and we get negative 4 equals that 3x, and so 3 goes into negative 4 thirds times. Don't forget, it's an ordered pair, x comma y. So there it is right there, okay? All right, so let's solve this system using any method. Okay, so I'm going to choose to do the substitution method because I have a 1x right there. So I subtracted 4y from both sides. So here it is, 2 minus 4y. And then I substituted that in for x right there. Now, most kids probably want to multiply this equation by negative 2, and that's cool. You'll get the same answer right there. But distribute that 2 through on the outside. I'll show you. I did that in the next part right there. So you get y equals negative 1. Don't forget, negative 4 times negative 1 is a positive 4. So we get x equals 6 right there. Ordered pair is 6, 1. Here's the same problem doing it the elimination method. Multiply this by negative 2 times negative 2 times negative 2. We get this red guy right here, and we still get y equals negative 1 and x equals 6. Either way, okay? It doesn't matter. They don't require you to do it a certain way. Okay, you're just looking for the correct answer, so whatever way works. Okay, here you guys, it's easiest to multiply this equation by 3, because then I'll get a negative 3y that'll cancel out with that 3y right there, okay? So there we go, and we get a fraction. Oh boy. Okay, so 4 thirds, and then plug 4 thirds back into any equation. I chose the very first one right there, and I got y equals 2, okay? All right, let's see, this guy right here. All right, we can make these both 6x's or both 10y, and since that's a negative, I think I chose the 10y's, you guys, because I don't have to worry about multiplying by negatives and get carried away with losing negatives. I'm good at losing stuff, you guys, especially when my brain gets so tied up with stuff and I forget negatives. So multiply the top equation by 2, that'll get me a plus 10y. Bottom equation by 5, that'll get me a negative 10y. So I get this red guy and blue guy right here. All right, and then we add these together. The y's cancel. 4x plus 15x is 19x, and 19 goes into 152 8 times, so it's negative 8. All right, that's x, and then I plugged it in for that x right there, negative 8, and we get y equals 6 right there, so it's negative 8, 6, okay? All right, here we can make these, I think I multiplied it by negative 2, I think, to make it a negative 6x right there, I think. Did I do? Yeah. Okay, so we get this red guy right here, and then we add those together, and we get y equals negative 2. Okay, plug it into one of the other equations, you get x equals 6. Okay, we're going to get to the application problems here shortly. Okay, this one I did again times -2, and when you do that, this side everything cancels out. Remember, you got to multiply that times -2 as well, -36, and then so we get 0 equals -18. Well, 0 doesn't equal -18, 0 equals 0, or -18 equals -18, but that's not a true statement, so there is no solution. Now, that just means they're parallel lines, you guys. They don't intersect anywhere. That's what no solution means. They're just parallel lines, okay? Okay, this one here, I'm going to take that bottom equation, multiply it times 2, and this time we get 0 equals 0. Well, that's a true statement. So that just means they're the same line. There's infinitely many solutions. Don't say all real numbers, because there's infinitely many more solutions that are points that are not on both of those lines, but both of those lines share all the same points, so there's infinitely many points. All right, okay, let's try some with fractions here. Okay, you guys don't like fractions, so let's multiply by a common denominator. In this one here, in this equation, it's times 6. In this equation, it's 12. All the denominators go into 12. All of these denominators go into 6, okay? That just means 6 times this, times this, times this, 12 times this, times this, times this. So I'm going to do that right there. Let's do the top first, you guys. So the 2 goes into 6 3 times. 3 times 1x is 3x. 3 goes into 6 twice. 2 times 2y is 4y, and then that cancels as 5. Same thing with this. The 12s cancel. The 12s cancel. 4 goes into 12 3 times. 3 times 3 is 9. Okay, now here's the system that we're going to use right there. Let me slide that over, and then I multiplied the top one by -5 to get -15x, and this one by a +3 to get a +15x. That way the x's cancel. Where'd my cursor go? And those cancel, and so we get 1y equals 2. All right, now it's easy. We did the hard part, getting rid of the fractions, so we get x equals -1, so it's -1, 2. All right, so how about this guy? Okay, this one we're just going to multiply times 6 times 6 times 6, and that's going to get rid of all the fractions right there. Okay, so we get that equation. It cleans up to that. Slide that other guy right down below it, and they're ready to add together because these are already opposite signs. So 4x equals 28, and 4 goes into 28 7 times, and then you can plug it back into any equation. I chose this one right here. Okay, so then when we do that, we end up getting y equals 1, so x comma y. All right, let's try a couple of application problems, then we'll be done. So to raise money, the Avid program at Bella Vista is selling shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8. Long sleeve t-shirts cost the school $7 each and are sold for $12. So the school spends a total of $2,500. Remember, it cost them this much for short sleeve and this much for long sleeve, and then they sold them for all of them for $4,200. Well, this is how much they sold the short sleeve, and this is how much they sold the long sleeve. So let's assign some variables. I'll let x equal short sleeve and y equal long sleeve, and the question is, how many of the short sleeves are sold? So we're going to be looking for x. Our x is going to be our answer. Okay, all right, so $5 it cost them for the shorts, and then $7 for the longs. Okay, and they've spent $2,500. Okay, and then here's how much they sold them for. They sold the short sleeves for 8 and the longs for 12, and so they made $4,200. There's our system of equations. I'm going to make these both 40x and -40x right there. Okay, so there they are. Add them together and we get y equals 250. Make sure you answer the question. Remember, we're looking for x. That's how many short sleeves are sold. So we got to go back and plug it back in and find out there's 150 short sleeves. All right, let's try one more. Trader John's sells mixed nuts of peanuts and cashews. So TJ's charges $2.80 per pound for peanuts and $5.30 per pound for cashews, and the mix sells for $3.30. How many pounds of peanuts and how many pounds of cashews should be used to make 100 pounds of the mix? Okay, I think I just solved for cashews. Anyways, we'll get it, no problem. So they told us 100 pounds altogether of the mix. So how many pounds of peanuts plus cashews is going to be a mixture of 100 pounds? Let's get the money involved, okay? So the money is $2.80 for the pounds of peanuts, $5.30 for the cashews, and then the mix is $3.30 right there. So we got the blue equation and the red equation. I'm going to multiply the blue guy by -2.8, And so that way it cancels out with the red positive 2.8. Okay, we can go ahead and add those equations together, and we get y equals 50 right there. So we get 20 pounds of cashews. Now I didn't say that, you guys. So we got 20 pounds of cashews. How many pounds of peanuts? Well, I didn't write it down. It should be also 80 pounds of peanuts. Okay, because it's they add up to 100 pounds right there. All right, you guys. I hope that makes sense. Take care.